Okay, so welcome everybody to this meeting. It's our members' images meeting, and it's a roundup of some of the members' images over the year. And I'm very happy to say we've got a good selection of images. Unfortunately, some of the people that presented these images are not able to be here tonight for various reasons, and I'll explain that as we go along. So a quick run through of what we're doing tonight, a few notices that I'll read out, and we'll have a news item from Len, followed by the presentation of members' images. And then we'll have a planetarium visit with Richard telling us what's upcoming in the night sky for the rest of the month and early January. Just a few notices. We are making a recording of this meeting, and it will be available hopefully on YouTube afterwards, but just be aware that it is being recorded. I encourage you to use the speaker view, which means that you just see the person that's talking and the presentation. So if you have questions, please feel free to ask them throughout, and we'll try and pick them up at the end of each speaker's section that's presenting the images. And if not, we'll pick them up right up at the very end. So, and then I'll tell you a little bit about our next meeting, which is actually on the 29th of January. And that's going to be from Mike Leggett, and it's going to be astronomical instrumentation before the telescope. The idea here is that before telescopes were invented, astronomy was still a science that was developing, and he's going to tell us all about how that happened. So before we go to the news item, I'd just ask you all to mute your microphones, and I'm going to hand over control to Len now, so he will take control and give us the news item.
Okay. Hopefully everyone can see that. If someone could give me the thumbs up. Excellent. Right, well, it looks like a repeat of last week, but it's not. But it's on the same theme, the news. Is there intelligent life in the universe? Never seem to chat. Oh, there we go. Right. Well, I'm sure that most of you know about the WOW signal. In the 1970s, it was an intense period of SETI, the search for extraterrestrial intelligence. They searched the galaxy, or the local galaxy, looking for signals from ET. And the huge radio telescope called Big Ear in Ohio found the WOW signal in 1977. The telescope output was generally recorded on this chart-like paper. And when a researcher saw this signal, he wrote WOW next to it. And ever since then, it's been known as the WOW signal. The multi-year SETI search basically produced no significant results, with the possible exception of this one signal. They repeated the search in the same area for years, but another signal was never found. So let's have a little look at a little bit more detail. Basically, this chart on the left, you can see you have time on the vertical axis and frequency along the bottom. And this white dot on the left here is the signal. So it shows that it was a very narrow band signal. It was within a 10 kilohertz bandwidth. The actual frequency of the signal was 420 megahertz, 0.3556, just 50 kilohertz away from the hydrogen line. So quite a universal marker. And then on the right here, you'll see the shape of the signal. And it looks as though it builds to an amplitude and then reduces, which it does, of course. And I've always known that this signal lasted for 72 seconds. But actually, that's not really the case. The telescope, the Big Ear radio telescope, wasn't tracking this object. It was just turning with the Earth. So, and it takes 72 seconds to pass an object. And as it approached the object, the intensity got higher and then reduced. So the signal could have lasted for minutes or even hours. But it's also another concern is, was it interference from Earth? Well, another good thing about the shape shows you that almost certainly it wasn't an Earth-borne signal, because it wouldn't have been that shape. It would have been quite different. So this is the last slide. So the signal came from the constellation of Sagittarius. This circular area is blown up here. And you can see that the signal occurred in one of these two lobes. Now, the reason there's two lobes is that the big ear had two horn feed receiving antennas, and they produced the two lobes. The ironic thing is, of course, the signal only came from one of those lobes, but because the output was combined, we can never know which one it was. So, but at least we know it's in that very specific area of sky. So now for the actual news. An amateur astronomer, Alberto Caballero, has now traced the signal back to potentially to a star that closely resembles our sun. The star eluded scientists in 1977. They looked at all the stars there, but we didn't have good enough records or telescopes to actually tell there was a sun-like star in one of those areas. But now there's the Gaia telescope all-sky survey, which I believe has recorded a billion stars so far, and is going to go on for another couple of years, and should get even more. And that data is released online for anybody to look at. And he searched that data and found just one particular star, which is very much like our sun. It's the similar mass, luminosity, just the same. We also know it's 1,800 light years distant, which is quite a way. I mean, in the context of the whole galaxy, it's not that far. Galaxy's 100,000 light years across. So 1,800 is close in that context. But in terms of being in radio distance from us, it is quite a long way away. There are other stars identified as well, but just the one sun-like star, which is probably the best candidate. So is this really a signal from intelligent life? Well, I thought a lot about this. I mean, the one thing against it, in my opinion, is the amplitude of the signal. I mean, we've sent signals out. I don't think we do it now. We're too concerned that somebody might come and get us. But in the past, people have put a megawatt signal into the Arecibo dish and sent that out. But if that had gone 1,800 light years, it wouldn't be this amplitude. It's not that it's impossible to create a signal like that, but we'd have to put a lot of time and technology into creating that kind of power of a signal. So that's against it, in my opinion. But then on the other hand, it's a narrowband signal. Nobody has got any idea how such a signal could be produced naturally. I mean, there might be a way, but it does seem very strange that it was produced. So I'm on the fence, and it could be alien life, intelligent aliens. It may not be, and that's the news.
Thanks for that, Len. That's very good indeed. And I'm taking control back again. So I'm going to now share my screen again, and we'll see what. So we're going to go on to our members' images, and I'll tell you just a little bit about this. We've got a selection of images tonight from various contributors. We've got some from David Hepwood, who unfortunately cannot be here. He's given us a small number of images. So I'm going to do my best to present those to you. Then Stephen Helsiger, he'll do his own, and Peter Rees will talk about his images, as will Pat Walker. Unfortunately, Martin Weston is not able to be here because of illness, and I'll try and present Martin's images. I must admit that it's a daunting task, so I'm going to have to read some script for that to give you some idea about those, but hopefully I'll be able to give you enough information that you can get some benefit out of it. And then we've got a selection of images from Bob Garner, just to remember Bob, who was a stalwart of the society. He was actually a committee member for a number of years, but he also was very active on WHAS, and he contributed a lot to our society. So we thought we might finish off the year by just recognizing that Bob did a lot of astro imaging as well. So let's go ahead and start with David Hepwood's. So David uses the Celestron C11, as you can see in this picture here, and he generally uses an Natick camera to do the imaging. And his first image here is the Antenna Galaxy. It's about 45 to 65 million light years away in the constellation Corvus, and it's actually a pair of interacting galaxies. They're currently going through a starburst phase in which collisions of clouds and gas and dust with entangled magnetic fields causes rapid star formation. They were originally discovered by Herschel in 1785, so they're quite an interesting collection of galaxies and a fair distance away as well. So that was taken from Hemel Hempstead, I believe. Next up from David is Comet Atlas. It was discovered by the Atlas survey on December the 28th, 2019, so it's a fairly new one. And I think it's got about a 6,000 year elliptic parabola, but unfortunately, I think it broke up into a number of fragments later in April this year. So David took this picture early on in the year. I think it was probably in February. Haven't got a date on it, unfortunately. But this was when it was pretty much at its brightest phases. And you need to be aware that I think Comet Atlas won't be able to be seen again because the number of fragments that it disappeared into made it very small. So it's a good opportunity to have a bit of history there with that one. Next up is the California Nebula. And he took this with a wide angle, relatively speaking for astronomical terms, 105 millimeter lens on his camera. And that's approximately, the image there is 14 moons across, just to give you an idea of how wide it is. The California Nebula is named because it looks like the state of California. I'm not so sure I see that, but a lot of these objects in the sky don't always come directly to hand. I think if you orientate it in a different vertical orientation, it might look like it. But anyway, it's in the constellation Perseus, and it's about 1,000 light years away from us. So next up for David is M81. He took this in LRGB, so natural colors, if you like. And again, it's a nice constellation, and it's 11.7 million light years away. So it's a fair bit away from us, and it's a very good example of a spiral. It has a diameter of about 90,000 light years. And as you know, it's located in the constellation Ursa Major. It's frequently imaged with M82, its partner as well, and I think we'll see some images of that later on. So at this point in time, I'm going to hand over to Steve.
Thank you very much. I can now share my screen. Do you want to? Right, so if you, so can you see, can everyone see that? Okay. Sean, can you see that full slide?
Yeah, that's okay, Steve. Yeah, I can see you okay.
Okay, good. So I've kind of split this into two halves. The first half is solar system and the second half is galaxy. I'm just going to sort of speed through these pictures really. These are in the main pictures I've taken this year. So this is the telescope I use primarily for solar system objects, which is a Celestron Edge HD8. So on an AVX mount, and I use a Lacerta auto guider for actually both my telescopes, but this is what I use for solar system. For imaging, I use three main programs: FireCap to capture the images. I use an ASI 120 mm or an MC, which is a color or monochrome camera, depending on what I'm using it for. I use auto stack Herts, which I think most people use for stacking the video files. Then I use Registacks for wavelet sharpening, and that's just for sharpening the images. So I'll just run through some things I've done this year. This is actually a highly reduced picture of the moon. It comprises of several it's actually a mosaic of several images. I think there's about 60 separate frames. Each frame comprises of about 5,000 individual images, which have been put together. And I've printed it quite large, and it looks nice. I mean, there's just a very small section of it. So yeah, I always enjoy doing taking pictures of the moon. The other thing interesting this year was Venus. We had many phases of Venus at the beginning of the year, and when it reached inferior inferior conjunction, it became a very, very thin and relatively large sliver in the sky. Mars, as everyone knows, reached opposition, and it was a bit of a challenge with the seeing conditions in North London. But the image on the right I'm particularly pleased with. Managed to capture some detail of Mars there. I actually experimented with a 4x Barlow, which I haven't done before. And it didn't lose too much detail. I also, so that's the best image I took of Mars, and the best of Saturn this year. Saturn, unfortunately, and Jupiter were very, very low, so you couldn't really capture it particularly well. So that's the solar system this year. Oh, sorry, the next thing is the sun. So I always enjoy taking pictures of the sun. So in fact, I'm cheating a little bit here. This was last year. This was a Mercury transit taken with the Lunt solar scope. That's quite a nice image of the sun with quite a lot of detail. I mean, again, like the moon, seeing conditions are very, very important. But again, that's a montage of the surface area and the prominences. There's another one showing very, very rare appearance of sunspots this year. So on to deep sky. This is a telescope I use for that, which is a 100mm refractor, again on an AVX mount with the same auto guide system. Certain things I invested in, which I've this year, which I've found very useful. Which one of them is a pole master, which allowed me to do far more accurate polar alignment, which allowed for sort of longer exposures. So the software I use for that for deep sky stuff is SharpCap, which is fantastic. Works really well with the ASI 294 camera, which is the camera I use. I don't do any narrowband photography. I only do one-shot color photography, because it's easier, and that after half an hour of setting up all the equipment, it clouds over and it's hopeless. So I try and do everything in 1-2 minute exposures and just capture a lot of them, and you can do the darks with the lens cap on. I also have ditched Deep Sky Stacker in favor of Astro Pixel Processor, which is a fantastic program, and it's completely changed the way I do things. So all these images are with Astro Pixel Processor. So this is the first one of the Orion Nebula. I took that about a month ago. It was still quite low, so when it gets clear, I'll be able to get that a little bit better. The obligatory Horsehead Nebula, again, same technique. Here are some other deep sky objects, which I'm sure everyone will recognize: Dumbbell Nebula, Crescent Nebula, the globular cluster in Hercules, and the Helix. That Helix Nebula I actually took from Spain last year. So again, that's a bit of a cheat. So onto galaxies. All these galaxies I've taken this year. Andromeda, everyone's favorite. Still haven't quite reached the level I would like to get, but I'm reasonably happy with that. You can get my pointer up. pointer. So yeah, you can see some hydrogen alpha regions here, the odd one. So yeah, it's not too bad. The Triangulum Galaxy, these are all kind of in order of distance, by the way. So the Andromeda Galaxy is about 2.5 million light years away. Triangulum Galaxy is around 3 million light years away. It's also in our local group. Again, this is a great galaxy for hydrogen alpha regions. You can see them sort of shining through here. The next old favorite is M81 and M82. So this is actually the photograph itself, which again is a montage of two separate panes stitched together. But you've got Bodes here and the Cigar Galaxy here. And again, it's always a challenge trying to pick out get the dust lanes and the hydrogen alpha regions, and also the faint arms. It's quite difficult from where we are, light polluted areas. The next one is the Pinwheel M101, which is, I can't remember how far that, I'm afraid the Zoom stuff is covering my notes, but that's the next furthest away. I think it's around 12 light years away. Absolutely huge, massive galaxy. At least 500 million stars in there. I've included the next ones because it's kind of interesting. I sometimes keep my old images. So this is the first image I took of M51, the Whirlpool galaxy. And it's interesting comparing that with one I took this year, which again, you've got all this structure here. These are all stars, which are being thrown out by the interaction of these two galaxies here. This is a starburst region here as these two galaxies interact. But I was very happy with this image, really. There's quite a lot of you can't really see it on this, but there's quite a lot of detail in there. 23 million light years away. And it's quite interesting, I think, comparing this, which I took in my back garden with my relatively cheap telescope, with Mount Palomar's version not all that long ago. So this is what Mount Palomar, the Hale telescope, took in 1970. This is the enormous size of it. If you have a look at that, if you can see that person there, you get a sense of scale of this enormous telescope, and that's the image it took. This is what I took from my back garden, and this is what Hubble has taken. It's slightly comparable at least. So further out into space, 42 million light years away, is the Needle Galaxy, which is 100,000 light years across. It's one of the rare edge-on galaxies. It's very, very pretty, lovely galaxy. And there are other galaxies as well in this field. And it's always quite nice to see if you can capture other galaxies within the main target. There was news of in May of a supernova in M61, which is in Virgo. So it was a clear night, so I trained my telescope on it, and sure enough, there it is. So that is actually a supernova there. First time I've managed to capture one of those. And almost at the end now. So, everyone takes pictures of the Pleiades, but there's a galaxy here, which you can only just about see, which is 400 million light years away. And I always think it's a test when you're taking the Pleiades. If you can see that galaxy there, then you've captured quite a lot of detail. But yeah, so that's the reason I've included this. I've got lots of images I haven't included, but yeah, 400 million light years away. What a thought. The light left that galaxy, landed on my camera chip, but it started. Those photons started their journey before dinosaurs were roaming the Earth. Well, a long time before dinosaurs were roaming on the Earth. Finally is probably my best image of the year, which is, again, a one-shot color camera of the Rosette Nebula. I took that, again, about 3 or 4 weeks ago. I'm quite pleased with that. Not a lot of data, actually. You know, there's only probably there 1 minute exposures. There's probably about 30 or 40 images in there with some darks and flats. And that's it, really. Merry Christmas, Happy New Year to everyone.
Thanks for that, Stephen. Did somebody have a question?
Yeah, Sean, it's Arabella.
Yeah, hi, Arabella.
Hi, can you hear me all right?
Yes, fine, thank you.
I just wanted to ask Stephen the difference between the two images of the Whirlpool galaxy. What was the difference in your equipment or the way you set things up?
Well, it's exactly the same telescope. The first image of the Whirlpool I took with an SLR camera without any experience of processing, and I wasn't guiding back then. The exposures were shorter. It's one of these things that you just get better with practice, and you know, just learning how to use the software and learning all the foibles. I mean, if one thing goes wrong in a chain, and it often does, then that can scupper the whole sort of night's imaging. So everything has got to be right, really. And yeah, it's just practice and patience, really.
Mm. Oh, well, they're amazing images.
Thank you.
Yeah, great, fantastic detail there on those images, I must say. I'm now going to hand over to Peter Rees. I'll run the slideshow from here, and Peter will hopefully give me instructions when to move on. We're doing this a bit by a wing and a prayer, so hopefully it'll work all right. So let me share my screen again, and we'll take it from there. So next up, we do have Peter Rees, and his images are just coming up. So you all know Peter. He's been a member of our society for a long time and does a lot of work up at High Top. So here's Peter's first image about his telescope.
Yeah, this is, can you hear me? Yeah.
Yep.
Yeah. This is my AstroTrack setup, just with a normal camera tripod and the AstroTrack with the polar scope and the SLR camera. Okay, next slide. Right, this is my current setup, and this is what the majority of my pictures have been taken with. It's a NEQ mount, an Altar triplet refractor, which is 480 millimeter focal length, so 80 millimeter diameter, and it gives a f6 focal ratio. I'm using Attic 314L camera with an Attic filter wheel and a QHY6 guide camera on a 400 millimeter camera lens. I've also invested recently in a Pegasus electric motor, and I've recently bought a pole master, but I think only a few of the images have been taken after I've set up the pole master. So during the lockdown in March and April, I was off work like a lot of people, and I took a lot of pictures in March and April of galaxies. These images were taken mainly in the Ursa Major, Coma Berenices, Canis Venticia, and Virgo. Okay, so if you could show the first slide. So this is the Leo triplet, M65, M66, and NGC 3628. M66 is the wider spiral, and the one in the bottom corner is the NGC one. This was LRGB, 100 seconds with the luminous and 60 seconds with the RGB. Okay, next slide, please. But this is my image of Comet Atlas. I took this on the 23rd of March, and to find it, I just put in the coordinates on my planetarium software, and luckily the camera found it, because I'd no way I would be able to find it visually. So I've got something there. I just used 15 seconds in luminous, and it's a stack of 10 images. Next slide, please. So this is my version of the Whirlpool galaxy in Canis Venaticia. It's LRGB. It's 200 seconds on the luminance times 5 and 100 seconds on the RGB. This was taken on the 26th of March. Next slide, please. So this is M81 in Ursa Major. I think this one's called the Bode galaxy. And this is 150 seconds in luminance and 50 seconds in RGB. I took this on the 24th of March. Next slide, please. So this is the M82, which is called the cigar-shaped galaxy. This was 100 seconds in luminance and 50 seconds in RGB. Next slide, please. This is my version of the Pinwheel galaxy in Ursa Major. This was 250 seconds in luminance and 80 seconds in RGB. And these are five images in each filter, all stacked together. I took this on the 26th of March. Next slide, please. Next one, please. Yeah.
There we go. Sorry.
Yeah, it's all right. This is M106 galaxy in Canis Venatici. This is 100 seconds in luminance. This is just a luminance. I will try and get the color data at another point. This was taken on the 24th of April. Next slide, please. This is M94, again in Canis Venatici, and this is called the Cat's Eye galaxy. LRGB, 90 seconds in luminance, 50 seconds in RGB. I took this on the 24th of April. Next slide, please. This is NGC 4490 and ARP 269. It's called the Cocoon Galaxy. It's a barred spiral. NGC 44, which is interacting with an irregular galaxy 4485. I took this on the 26th of April. Next slide, please. Oh, yeah. This is the Virgo cluster. So I pointed my telescope to the deep sky field. I think it's very close to the deep sky field that Hubble took. And I only did it in luminance, and I left it for 150 seconds times 10. And some of these galaxies are over 50 million light years away. There's quite a few galaxies here. There's M86 in the center, M84 on the right, which is an elliptical. There's NGC 4435 and 4438 bright ellipticals on the left side. Yes, and yes. Next slide, please. This is M100 in Comet Berenices. There are also some other galaxies here. NGC 4312, which is above to the right, and NGC 4428, which is above to the right. So there's one directly above and one to the right. I took this on the 19th of April, and it's 5 times 150 seconds in luminance and 5 times 60 seconds in RGB. Next slide, please. This is the Needle galaxy in Comet Berenices, NGC 4665. This was 120 seconds in luminance and 60 seconds in RGB, which I took on the 23rd of April. Next slide, please. This is called the Sombra galaxy in Virgo, M104. Luminance was 100 seconds times 5. RGB was 50 seconds times 5, taken on the 22nd of April. Next one, please. This was exactly the same image, but I used pin light in Photoshop blending mode to try and bring out some more detail. Next slide, please. Right, next image was Comet Neowise. This was in the 19th of July, and Don Doherty and I went up to High Top, and this was about the best night of the comet. And I got a wide-angle view of the plough, and then the comet just by the dome there. So this was taken with a Canon 70D 18mm f4 ISO 800 at a 1 second exposure. Next slide, please. This was Comet Neowise taken with the same camera with my 70 to 200mm zoom at 200mm. And this was a stack of 4 times 5 seconds at f5.6. When you stack the images together, the color gets washed out of the images. So my next slide, this was me trying to put the color back in again. I used the program called Astro Images to stack all these images, and then I processed them in Photoshop afterwards. Okay, next slide, please. So now we're back in September, and this is the NGC 7000, the North American nebula. This image was taken in hydrogen alpha, 175 seconds times 5, taken on the 20th of September. Next slide, please. This is Gamma Cygnus. There's a lot of nebulosity around this star. This was taken in hydrogen alpha, 200 seconds times 5, and oxygen 3, 200 seconds times 5, taken on the 14th of September. Next slide, please. So in October, there was the opposition of Mars, and I decided to use my longer focal length camera, which was a Celestian SE 6-inch, which is f10. It's about 1,000-meter focal length. And I used an image source camera, the DMK21AU, which is a color camera. And I did a minute exposure, minute video, and then I stacked it with Registacks. Next slide, please. So this was the same setup, but I used a 2.5 times Powermate, which is more than doubling the focal length. Next slide, please. And then while I was out photographing Mars, I then photographed the moon, and this is the Gassendi crater in Mare Humoran. This was taken on the 27th of October. And then my last image, another one of Mars, taken on the 24th of October. Similar setup with the Powermate again, with a 1 minute exposure and then stacked with Registacks. And that's my lot. Thank you.
Great, thanks for that, Pete. That's brilliant. Good
Yeah.
to see some of those. And nice to see the Neowise up at High Top. We went up as well and had a couple of good images. It was a nice comet to see. So moving on from that, we've now got Pat Walker, and Pat's going to talk us through his images. So this is Pat's first image. Are you there, Pat?
All right, forgot to unmute the microphone.
That's all right, don't worry.
Yeah, well, this year I've been very limited in what I can do, because I developed a problem with my leg and it very limited my mobility. So I've stuck to opportunist shots with any camera that sort of came to hand. And one night I walked down the garden and I saw the setting sun over right on the apex of my rooftop. And only having the mobile phone in my hand, I took a shot of it. And I actually took 43 shots. And suddenly, when I looked at it afterwards, I noticed this, which is a sort of a round object. And I thought, well, that's a bit weird, but I couldn't figure out what it was. Anyway, about 10 days later, I took another 43 images of the sun, which was now here, but the spot was there again. Well, I thought this must be investigated. So I consulted my software, I've forgotten the word. I'm losing my words here.
Your planetarium
software. And I realized the object was Venus, because if you compare the two photos, the first one's it's up there. Where is it? Somewhere up there. Oh, there. And the second photo, it's moved further in towards the sun. So anyway, I finally worked out that it was Venus, which was actually ahead of the sun at the time because it was in the morning sky. So, and it was heading into the evening sky. So, as October approached, I then took the next image, and by which time I'd acquired a Bresser astronomical camera. And this was Venus, once again, heading into the morning sky. And I'd never used the camera before, so I said it's a bit of poke and hope, I must admit. Still, it came out all right. Afterwards, I stacked the video in Registacks and tidied it up in Photoshop. Next one, Sean. A bit later on, when it got dark, I was still out there, and I was sort of looking around the sky with my 9-inch telescope, and I landed on a double star. I realised it's Aldebaran. So I took a 23-second video of that. This time, I decided to try out the camera stacking software. Still learning how to use it. Once I'd created the bitmap again, I tidied it up in Photoshop. Next one, Sean. Oh, I was going to say, you could see the two distinct colours of the double star. That was overexposed, and the other one came in red. By now, a bit later on, the moon had risen, so I just took a couple of random shots of the moon, one in natural colour and one through my H-alpha filter to see what it looked like. Needless to say, the clouds came over, ended observing. And the next one, Sean. This is the, oh no, that's the H-alpha picture I took of the moon. Now the next picture was actually 2018. I noticed a 2-day crescent moon, and it sat right down on the top of the apex of my roof. So this time, I turned the telescope on it and just held my small digital camera to the eyepiece, which is a 25mm eyepiece. And I managed to capture this. 2 minutes later, it had gone. So, that's how close it was. Literally a snapshot. I thought it's worth trying, and it came out. Sometimes it's good to try it and see what happens. Recently, next one, Sean. Yeah, recently, early December, I bought an iPhone holder which clamps onto an eyepiece, and I didn't have much time. The clouds were rolling in thick and fast, and I took I think it was a 10-second video of the moon. If you look carefully, you can see the clouds rolling in right across the moon. Don't know if you can play it again, Sean.
Yeah.
And say about 2 minutes later, it's gone. So that's, as I say, I haven't been very active. That's it.
Great. Thanks for that, Pat. Very interesting indeed. We'll now move on to Martin Weston's selection. As I say, unfortunately, Martin can't be with us tonight, so I'm going to do my best just to run through his pictures. I'll not be able to do them the justice that it deserves, but I'll do my best. So first of all, Martin's setup, I'll just move this slightly out of the way. Okay. His telescope consists of a Skywatcher on an EQ8 mount and an Altair Astro 250 astrograph. He's got a Vixen A62 wide field APO, and he uses a QSI 660 CCD camera with off-axis guider. That's a Starlight Express Lodestar. He uses a Canon DSLR 60DA, which is the adapted one for astronomy, and a Pegasus Ultimate Power Box and a Pegasus autofocuser. For software, he uses Pick Insight, Deep Sky Stacker, and Photoshop. He uses a sequence generator for imaging control as well. He also has a portable setup, which consists of an EQ6 with a Vixen 103, AX103 refractor, and uses Williams Optics, OpticStar 71 APO, and a 50mm optics, William Optics guide scope, using a QSI 660 again for off-axis guider control. Using the Nikon D810 SLR, a red dot finder, and so on. Software for that setup is the Pix Insight, Deep Sky Starker, and Adobe Photoshop as well. His first image here is the Cygnus loop. So basically what Martin said about this is if you'd been here several thousand years ago and looked up at the sky on a clear night, you'd have seen a very small but a very bright object flaring brilliantly some 15,000 light years away. That would have been a massive supernova that gave birth to what we now call the lovely and wispy Cygnus Loop Nebula. It's not certain just when the blast would have been visible on Earth. It occurred 5,000 to 8,000 years ago, and in any event, would have taken up to 1,500 years for its light to reach us. So this was imaged by Martin from Spain using the EI that he spoke about to us a few years back at a society. Next image is the Eastern Vei Nebula. Very colorful here, and he's captured quite a part of that section of the Eastern Veil. It's also known as Caldwell 33 and is a cloud of heated and ionized gas and dust in the constellation Cygnus. It is located about 1,470 light years from Earth. It is part of the Cygnus Loop, which is a faint supernova remnant that exploded approximately 7,000 years ago. From the moment that the star source exploded until now, the Cygnus Loop supernova remnant expanded to a diameter of approximately 3 degrees on the sky. That's almost 6 full moons. So this was imaged last year with a Vixen, a VX103 APO, and a QSI 660 CCD. The next image is the Western Veil Nebula, and it's catalogued as Caldwell 34, also less formally known as the Witch's Broom. It's part of the Cygnus Loop supernova remnant. As the debris from the explosion move at very high speeds through space, they heat up the surrounding gas to millions of degrees. And as it cools, it creates the colorful glows in the picture here. The bright star in this frame is 52 Cygni. It's superimposed on the nebula, but physically unrelated to the supernova remnant. This was imaged at the same time as the other Cygnus Loop images. The next one is the Crescent Nebula. It's an emission nebula located in Cygnus as well. It has an apparent magnitude of 7.4 and is about approximately 5,000 light years from Earth. The nebula occupies an area of 12 by 18 arc minutes of apparent sky and is designated as NGC 6888. And it also features a Wolf-Rayet star at WR136 near its center. So that's the bright star you can see in the center. A closer up view of that showing the star. The Wolf-Rayet star is 250,000 times brighter than the sun, with a mass 5 times greater. Before the star entered its Wolf-Rayet phase, it ejected a shell of hydrogen gas and became a supergiant about 180,000 years ago. That shell continues to expand at 80 kilometers a second. A much faster stellar wind generated after the star entered its Wolf-Rayet phase travels at 1,700 kilometers per second and results in the intense heat generated by an exposed helium layer along with the boundary between the surface and the star and outer space. This was imaged in May 2020 from his home in Wheat Hampstead using his Altair Astro 250 and the QSI 660 CCD. It was done in narrowband. Next up, part of the California Nebula. This is a large, long nebula, and as far as deep sky objects go, the California Nebula is about 60 light years across and roughly 1,500 light years away from Earth. The next one everybody will recognize is the Crab Nebula, M1. So in 1054, the Chinese astronomers took notice of a guest star that was visible for nearly a month in the daytime sky. What they observed actually was a supernova explosion, which gave rise to the Crab Nebula, I beg your pardon. a 6 light-year wide remnant of the violent event. With an apparent magnitude of 8.4 and located 6,500 light-years from Earth in the constellation Taurus, the Crab Nebula can be spotted with a small telescope and is best observed in January. This image was done in January 2020 from his home in Wheats Hampstead using my 10-inch RC and QSI 660 narrowband CCD. Up next, we've got the Horsehead Nebula. Everybody knows this. It's a very famous one. Stephen also spoke about that, so I won't really dwell on that one. Next up, Elephant's Trunk Nebula. This is an elongated dark globule and part of a region of star formation that lies 2,450 light years away from the constellation, from us in the constellation SWHAS. It's a region of dense gas that's being compressed by the intense radiation and stellar winds from nearby massive star, which lies to the left of the cloud. And that again was imaged from his home using a Vixen AX103S narrowband. Martin's next image is Messier 57, the Ring Nebula, which we all know and love. And it's a planetary nebula, and it happens when the star sheds mass at the end of its lifespan. The core of the dead star remains in the form of a white dwarf and ionizes the surrounding gas. The star that created the Ring Nebula thought to have been several times more massive than our Sun, and this event produced the Ring Nebula that is estimated to have occurred about 4,000 years ago. The Ring Nebula is about 1 light year across and is expanding at the rate of 1.5 million kilometers per day. It's approximately 2,000 light years from Earth. The Owl Nebula, also known as Messier 97, is famous planetary nebula in Ursa Major. It's 2,000 light years from Earth and has an apparent magnitude of 9.9. It's designated as NGC 3587 in the New General Catalogue. Its name of the Owl Nebula because of its appearance on larger telescopes where it reveals 2 dark patches that look like the eyes of an owl. I think you have to have an orientated in the correct direction to see that. We've not noticed that as well with other nebula, including the Eskimo Nebula. So next up, Martin has got the Orion Nebula, another very nice picture of the Orion Nebula, M42. It's 1,500 light years away in the constellation Orion, and it's relatively bright with a magnitude of 4. Because of its brightness, the prominent location just below Orion's belt, M42 can be spotted with the naked eye, while offering an excellent peek at stellar birth for those with telescopes. It is best observed in January, and this was imaged in January from Wheat Hampstead using his Vixen AX103S. Nice image here of the Pacman Nebula. It's got various names, NGC 281, IC11, or Shapless SH2 184. It's a bright emission nebula and is part of an H2 region in the northern constellation of Cassiopeia, and is part of the Milky Way's Perseus spiral arm. This is a 20 by 30 arc minute size. It's also associated with the open cluster IC 1590. Several Bok globules and the multiple star B1 can be seen. Its radius is about 48 light years. Distance from Earth is about 9,500 light years. And moving on to the next one, another picture of the Pleiades, always a very nice object to image. It's a group of more than 800 stars and is located about 410 light years from Earth. It's in the constellation Taurus. It's known as M45 as well. Most sky watchers are familiar with this, which looks something like a smaller, hazier version of the Plough in the night sky. Next up, we've got M51, the Whirlpool galaxy. It's very graceful with winding arms. It's a majestic galaxy. M51 appears like a grand spiral staircase sweeping through space. They're actually long lanes of stars and gas laced with dust. Such striking arms are a hallmark of the so-called grand design spiral galaxies. And M51, also known as the Whirlpool galaxies, these arms serve an important purpose. They are the star-forming factories, compressing hydrogen gas and creating clusters of new stars. That was imaged from his home in Wheat Hampstead using his Ritchie Chrétien scope. Next up again, we've got M81, that's Bode's galaxy. We saw M82 earlier as well, and these two are very often paired together, as I mentioned. It's a grand design spiral galaxy in Ursa Major, and is one of the brightest galaxies in the night sky as seen here on Earth. Bode's galaxy lies approximately 11.8 million light years from Earth, with an apparent magnitude of 6.9. It's located about 10 degrees northwest of Dubney. That's the corner of the plough, and this was imaged last year from his backyard. Next up, we've got a small selection of images from Bob Garner. Over the years, we've collected many, many images from Bob, and I've just whittled down a few from him. Here's a picture of Bob at high top. He was up there for the transit of Mercury, and you know very well that Bob helped many people get into astro imaging, both here at SWHAS and at WOLAS. And he did also help out a lot with the maintenance at high top, and we're very grateful for all his contributions to us. Here's Bob's telescope, and it's mounted on an astrophysics mount. And WOLAS did a collage that I thought was very nice of some of Bob's images that he presented to them. This was supplied by Robin Scadule, and we showed it in our newsletter just after Bob's death. But I think it's a very nice collection of images that Bob produced over the years for WOLAS. I'm just going to run through some of the images that Bob presented to us. As you know, Bob never liked to take an image of something that was straightforward. He always went for very obscure images, and he had a particular liking for doing the ARP objects. And here you see interacting galaxies imaged by him in 2012. Some more ARP images. I'm just going to whiz through these because I don't have any detail about the exposures and so on. That was all in his notes. But it gives you an idea of the sort of objects he did. Able catalogue as well, of course, was a favorite of his, and particularly planetary nebulae. So here's a selection of some of the Able objects. And the NGCs, of course, as well. It's strange to see these sort of images where you've got a star field and then you've got some what looks like a frog spawn in the middle of it all. But that's one of the interesting things about doing astro imaging, and particularly planetary nebula. There's so many different colors available there. That's the Crescent emission nebula in Cygnus. And Bob also liked to take a look at some distant galaxies, and he often took galaxies that were 7 million light years away, and in fact a few that were billions of light years away as well. Here's some more images of the Vandenberg 132 area of nebulosity, part of the elephant's trunk. Here you can see it from a different orientation than we saw before. An emission nebula in Auriga, interesting colors there as well. The Iris Nebula, very purple in hue there, and another galaxy, the Electric Arc Galaxy, imaged from 2012 in the Pegasus area. Here's a reflection nebula in Cephus, and that was imaged in 2012 as well. He liked the shapless images as well, so the shapless catalogue, he had many of those that he showed us over the year. And these show great detail in the star formation and dust lanes there. And of course, the Ring Nebula, as we saw earlier. Crab Nebula, that was one of his, he didn't do too many general objects, but a few of the galaxies and this one were ones that came up often. This is an odd one, and I just say a few words about this because I didn't really know much about this nebula. I didn't even know how to pronounce it, but I'm told it's Gubadi-Gihan. And if I've mispronounced that, I apologize, but that's the best that I can do on it. It's a little known reflection nebula, similar to Hubble's Variable Nebula. The nebula changes brightness and shape over months and years. In the years past, it has been a challenge even for an 18-inch scope under dark skies, but Bob managed to capture this image, and it was much brighter then, making it a perfect time to detect it, particularly with smaller instruments. Gubadi Gehan was an Armenian astronomer, and he discovered this in 1977, so it's a relatively recently discovered object, doing a survey for the Herbig Hero objects. Today you can see a fan-shaped object towards the center of the screen here, that's it. And it appears immediately to the northeast of the star. This reflection nebula appears to be the outer edges of a hollow shell that has been carved out of the interstellar medium surrounding the gas. The dust on the outskirts of the shell is illuminated by the star, and as the light passes through the dusty cloud, it's absorbed and scattered. The blue light is most easily scattered, so the nebula appears blue. As the star varies in brightness, so does the nebula, and it seems to change shape as well. I thought that was quite an unusual one. I'd never come across that one. So NGC catalog, Bob did most of what we know in the NGC catalog, and here's NGC 6504 in Hercules. And it's 140 million light years away from us, and it's a 13th magnitude galaxy, so it's well down there. NGC 6543, colorful, and then Nova 2013. Some more Shapless, another NGC. Some of these look like UFOs in space. The NGC 2371, very interesting because it shows the outbursts on the side. And more recognizable ones, the Monkey Head Nebula, IC 1871, and Emission Nebula in Cassiopeia. And of course, the Cone Nebula, NGC 2264. Another Shapless Mission Nebula in Auriga. And a couple of standard images, the M51 Whirlpool, M101, and the supernova that happened in M82, and NGC 2022, an edge-on spiral galaxy in Ursa Major. ARP1, and it's also called NGC 2857 in Ursa Major. You can see many other galaxies as well in this picture. If you look, you can see in the background. So here we got M97, the Owl Nebula, and you can see the central stars very well in this image. And some more Able images that he took. This is Able 3, Shapless, the Pacman Nebula, which we saw previously, NGC 1501, and Seyfert's Sextet Galaxy. Very difficult combination to get an image of, but done by Bob in 2015. Some more NGC, John. And Able 39, it's a planetary nebula in Hercules, imaged in 2015. And another Shapless SH2 114, it's an emission nebula in Cygnus. You can see the wisps very clearly on that one. And an edge-on spiral galaxy in Leo, the NGC 3628. And a pair of interacting galaxies, they're called the Siamese twins, NGC 4567. These are in Virgo, and he imaged that in 2016. Shapless 284, a nebula in Sagitta, taken in 2016. Planetary nebula in Cygnus. And NGC 6804, planetary nebula in Vulpecula. NGC 6842, another one in Vulpecula. And we're getting close to the end of his images that I've selected tonight. Another Shapless here to 112 in Cygnus. He took that in 2017. And here another planetary nebula in Aquila, NGC 6804. NGC 70, 94, a planetary nebula again in Pegasus, imaged in 2017. And SWHAS 290, sorry, beg your pardon, an emission nebula in Vulpecula. SWHAS 142, another emission nebula, this time in Cephus. And that's the end of our images. And I would really like to thank all our contributors for sending in their images. And now we're going to move on to the planetarium. So if I could ask Richard to come on, and I will make Richard host if I can. Okay, good.
Thank you. Well, good evening, everyone. I'd like to try a slightly different view this time, slightly different approach. Now, we've seen a lot of pictures, they're really good. A couple of comments, just a couple. The Owl Nebula was going to be called the Monkey Nebula. It got that designation because the Earl of Ross thought it looked like the visage of a monkey. He instead, it was the same person that called the Crab Nebula what it's called, because he saw these strange appendages sticking off of it. So that's a couple of names and how they got there. But what we're going to start with to see now is I'm going to be looking at the stars themselves, because what we get when we're looking at the winter sky, we're actually looking at the Orion arm of the galaxy, and there are a lot of bright stars that are actually very close to us, and they're in a particular small area. And the interesting thing about them is that many of them are different types. They range from O stars down to M stars. So it's pretty much the whole range of the spectral sequence. And we're starting off with up here, the one here, Aldebaran, which is in a beautiful region of sky. It's actually, if you increase the magnification a little bit, you can see that there's quite a cluster of stars around here. That is the Hyades, and the Hyades looks as though Aldebaran is actually in the Hyades. But we get a three-dimensional view here, because in fact Aldebaran is only 65 light years distance, whereas the cluster, the Hyades, is actually the same distance again, so it's twice the distance. It's an interesting cluster, simply because it's so close. It's often used as measurements of typical clusters and how they move. So it's kind of a prototype cluster that can be used for studying other further distant clusters. Aldebaran itself is a K-type star, which means that it's orange in colour, and it's a little bit hotter than Betelgeuse, which is this star down here, which is an M-type star. So you've got two reddish stars, but they're not exactly the same. One's hotter than the other. Now, also in this constellation, which of course is Taurus, you've got the streams coming off here, two horns. And up here we have the Pleiades. Now, originally the Pleiades were a separate constellation. Now, I'm picking this tip because we've seen a picture of the Hyades, several views actually. I'm going to try enlarging this a little bit, just to see what sort of definition we get. But I know that the actual picture presented is nothing like as good as the ones that you've seen. You can see here, though, that there's several bright ones and quite a few faint ones. Now, there's a little feature here which is very noticeable in binoculars. If you look at the Pleiades, you can see that there's a little kind of line of stars in a V shape that drops down. Now, it's sometimes referred to as the hockey stick. I sort of discovered it myself. But of course I didn't. I just found it with a pair of 10 by 50 binoculars, and it always reminds me of that sort of discovery many years ago. There was something rather strange or something unusual about the Pleiades. Now, this star here is a multiple star. Well, in fact, you could say they're all multiple stars, but in fact, that particular one has three other stars right next to it, much smaller, much dimmer. but they show up nicely in a pair of binoculars. At least they do if you use a good high power on a pair of 50mm binoculars. You should be able to see them. They're quite interesting to look at, and they're quite a challenge. So there's a couple of things that you can do just by looking at the Pleiades. You can get some, of course, all of them have names. They're actually the daughters of, I forget who it was now, but they're running away from this figure here, which is, of course, if we come back to where we were, which is Orion. Orion is here, and obviously there is the Pleiades back again. So there's a couple of things that you can look at with binoculars, because certainly this area here with the Hyades and Aldebaran is actually really interesting, and as I say, it's a good example of a 3D view of space. There is also another NGC cluster tucked in here, which is even further away. Now that taking a line around these bright stars, you've got Aldebaran, then you come to Capella. Now Capella is actually it's not one star. It looks as though it's one star. It's actually what we call a spectroscopic binary. Spectroscopic binary is a double star that you can't actually separate with a telescope, and you see it on a spectrum where the lines are double. You can see there's two sets of lines superimposed. The two stars that make it up are actually G-type stars. So in a sense, they're very similar to the Sun, but you have to remember that they're giant stars. So although they're the same spectral type as the Sun, they're much bigger. And of course, if you take that line round even further, you come to Castor and Pollux. That's Castor there, that's Pollux. Now, it's strange because Castor is two A-type stars, so they're very white. They're very white stars. And actually, that is another double star. It's composed of at least 6 stars in that system, 2 of which are really brilliant. They are the 2 stars that make up Castor itself, and they're easily separated in a small telescope. But you can do it with a 2-inch refractor now. A very small telescope will show that. And in fact, when I first started observing, which is a long time ago now, they were much closer together. And over the period that I've been observing, which is about 50 years, a bit more than that, not all the time, but over the years, and that they are much easier to observe now. At one time, they were on the limit of a 3-inch refractor I owned at the time, and you had to use a high power to see them. But now they're really easy. And it just goes to show you that you can see movement in the stars, but you have to be prepared to wait a long time. Next to it, of course, is Pollux, which is another interesting star because it's, again, a K-type star. And then we come down to Procyon. Now, Procyon is the lesser dog, Canis Minor. It's the brightest star. In fact, some people would say it's the only star. We know that it has a white dwarf companion, but as far as visual observation is concerned, you can only see the one star. And that is an F-type star. So it's not as bright as an A-type star, not as hot. For that, we have to come down here to Sirius, which is only really bright because it's close to us. It's a bit of an imposter in a way because it shines, magnitude is about minus 1.24. So it's a bit much brighter than the first magnitude star, much brighter than the 0 magnitude star. But the reason for that is it's only 8 light years away, which is much closer than the other stars. And yet all of the stars I pointed out, except for Betelgeuse, are actually within about, 60 light years of the Earth, which it sounds, when I say only, that's a huge distance, but it's not in terms of stars. So Sirius is a type A type star, and we do know here again that it's actually got a companion, a pup, and of course these 2 stars were in Greek mythology were Orion's, there's Orion here. They were his hunting dogs. Now we come back round here and we come to Rigel. Now this is a real exception because again, it's a very, very hot, bright star, but it's a long way away. Now, compared to Sirius, which is much brighter than Rigel in apparent magnitude, is actually, Rigel is much the brightest because really estimates of its distance vary considerably, but it's roughly settled that it's about 1,000 light years. So it's very, very distant compared to Betelgeuse, for instance, which is 420, somewhere around there, 450. And Aldebaran, which at 65 is very close. And so all of these stars, they have different characteristics. And it's interesting sometimes on a night when you get a really quite nice dark sky to compare the colours. Now, I'm aware that a lot of people don't see much colour in the stars now. And I have to say that I think that light pollution has an element to play in this, because light pollution reduces or tends to give the colour a sky of its own, gives the sky a colour of its own, which tends to mute the rather subtle colours of the stars. If you go somewhere where the sky is really dark and you have a look at the stars, you'll find that you can tell differences much greater. The fact that Rigel is very, very slightly blue, and Betelgeuse is quite obviously a reddish orange. Now, you may remember that last year we had a business with Betelgeuse fading. Well, that was sorted out, and as to what it was, and it's not a permanent feature. It's not actually that Betelgeuse is about to go supernova anytime soon, but it's an indication that there are clouds of matter that surround the star, and probably like all red giants, its actual shape isn't round. It's probably quite sort of blobby shaped, with lots of dark material that's coming off of it, blowing around in front of it. So that's just an indication of some things that you can see quickly with binoculars and with a small telescope. We're going to go a little bit deeper now, just a little bit deeper. I'm going to come up with Orion, bring it round here, so that we can see it a bit clearer. Now, unfortunately, there seems to be no way of getting rid of these names, but I don't think there is. No, there isn't. Not those. They tend to stick up. Okay, so you've got the three stars here of Orion's belt: Mintaka, Anilalem, and Alnitak. Now, the celestial equator actually passes through, or very, very close to Mintaka. So that means that Orion is a constellation that's visible at any country in the world. The Australians see it upside down, which is very unusual. Having done it myself, it's really peculiar, but that's how it is. But we see it the right way up, if you like to think of it that way. And of course, it's quite a compact constellation, and it's striking because of the fact that it has this very distinctive shape. And the fact that it's directly on the celestial equator is a point that you almost wonder if that's an accident, that somebody's decided, well, we'll have the equator through there so that everyone can enjoy the features of Orion. However, the Chinese see things differently, and to them, this is one constellation, and that's something else. It's really weird. The Western culture is the only real one that considers this to be an actual constellation figuring a person. Now, Mintaka is a double star. It's pretty easy to see in telescope, and it's quite a nice object if you've got a good reasonable pair of binoculars, and they will be separated in 10 by 30 pair. I know because I've done it myself. So that's quite a nice little object to look at. And also there's a cluster here, which is called NGC 1981, and that has the odd red star in it. It's quite nice to look at. And of course, here we can see the beginnings of the Orion Nebula coming out, and you can see exactly where it's located. And this very nice double star down here, which is very obvious in binoculars and very nice to look at. And really, Orion has got so many objects in it that it's a challenge to pick them out, and you can spend the whole evening looking at objects in this constellation. Now, see these three stars up here. Now, these three stars, that gap there between them would hold the moon. If you could move the moon so that it fitted, so that it went through those three stars, it would actually fit between them. That gives us some idea of the size of the moon. So most people see it as much bigger than it really is. In fact, there is a test that you can do. If you get a 5p piece and you see a full moon, hold the 5p piece up to your arm's length and look at them and hold it against the moon, and you'll see that actually the 5p piece will cover it completely. So when we think about eclipses, like eclipses of the sun and the moon, particularly a total solar, that lining up is extremely accurate, and it's quite a remarkable thing that we can actually see. The reason we know about the corona is because of eclipses of the sun. So, you know, with all these lineups, you do wonder if somebody was thinking, well, we give them a few challenges when they look at the sky. So there's another feature that I want to point out before I forget. In the night of the 13th to 14th, there will be the Geminid meteor shower. Now, this radiates from a point that actually changes. It's this line here. If you take that line there, there's Castor, there's Pollux. That is quite a strong shower. Now, I remember seeing it several years ago and being really, really enthusiastic, and you know, this is really good, and I saw it, and the great thing about it is you don't have to stay up all night to watch it, because if the moon's out of the way, which it will be by 13th, 14th, you will be able to see quite a few meteors if it's clear. The other thing is that a few years ago, I did this same test, if you like. I went out, it was a nice night, I got a peak night, I thought, right, see a few meteors. And I didn't see a single one. And I was quite bemused. And I actually started shouting at the sky, the daft things you do in a garden on your own. And I thought, this is stupid. You know, why am I shouting at the sky? You know, it can do what it wants. So, but it's worth a look. And if you get a clear night, then please do have a look and see if you can see any meteors. So again, you've got Orion's Nebula here for that, suitable for binoculars, telescopes, anything you like is really good to view that with it. Strangely, it wasn't discovered by Messier. Certainly, it's known well before then. But the funny thing is, Galileo looked at it and looked at this area here and didn't see the nebulosity, and it was left to a guy called Orion who discovered it a few years later. It's really strange that he didn't notice that, but then his telescope had a very small field, and he might have thought it was just a cloud. He wouldn't have necessarily been looking for it. There is another cluster which I'm going to point out, which is here, and that is M35. Now, I was going to show this, but to be honest, we've seen so many good pictures this evening, and I know that it isn't a particularly good picture, so I won't. And it's better if you actually go out and have a look. You can see it in binoculars. It's very easy to find in binoculars because it's this near this star here, which is Iota. If you take this is the box, if you like, of Gemini, and line up here, and you find it just there. You can't miss it. It's pretty bright. It wasn't discovered by Messier. It was discovered in 1750. Several observers, including John Bevis, who incidentally was also the first person to observe the Crab Nebula. And he actually put it on an atlas. He made an atlas of stars, which is very rare. It's an atlas of various constellations, and it was that observation that showed that Messier used to actually find M1. He reported that it had been reported by John Bevis of London. So same guy seems to have found this little cluster here. It's a nice cluster. There's a red star in it. It's also got curves of stars wheeling away from it, and it's very nice in any telescope you like. And also there's another cluster which is even further away. That one is 3,700, 800 light years away. But there's another one twice that distance that you see on the fringe if you've got a nice dark night, and that is NGC 2185, which is much more distant. It's twice as far away, and it's just a little smudge of light. Although if you are into imaging, you will actually separate it into stars. So I'm going to try something now, which we tried last time, just to see if we can do this and get it right. So let's go that way. Okay. Now, there we are. We wind back. We go back in time. So go back. Doing this a bit slower than the last time. Stop. Here we are. Now this will be the conjunction of Jupiter and Saturn. Now this is on the 21st of December at sunset, just before sunset, and they will actually be so close that they will be seen in a telescope in the same field with a moderate power. You can see how high I'm blowing this up. You will actually be able to see Saturn and Jupiter and their moons in the same field. Now, I said it was very rare last time, and in fact it is extremely rare. The last time that happened was as long ago as 400 years ago. So it's worth getting out there and having a look and just seeing what you can see. So with that, I'm going to conclude. One or two things I'd like to say. One is that I'd like to thank Sean for taking interest in this and helping me to sort it out, and particularly Graham, who spent half an hour with me yesterday while we tried to get around the foibles of the fact that there are several different versions of stellarium that don't necessarily all work the same way. So I hope that that's provided some interest and some things to look at over the next couple of or few weeks until we get to the new year, where we'll be hopefully free of this dreaded COVID situation. But I think that's way off yet. Okay, thank you, Sean.
Okay, Richard, thank you very much for that. It's very interesting. And as ever, you are a font of knowledge on all of these things. And I think at that point, we'll wrap up the meeting tonight. And all I want to say is thank you for all the contributors. And we'll see you again in January for our meeting at the end of January. But don't forget also the WOLAS meeting on Monday. You're invited to that as well. And it'll be a talk by Dr. Simon Steele. He'd be speaking from the SETI Institute in California. Remember, they're 8 hours behind us, so it'll be their afternoon. And it's going to be following on from what Len's topic was, the search for life in the universe. So that could be an interesting follow-up for you. And I've sent you the link, but if anybody has any difficulties, make contact and I'll send it again to you. So all I'd like to do at this point in time is thank you all for attending, and We'll see you in the new year. Hope you have a great Christmas and you and your families stay safe. And see you next time. Happy Christmas,
you.
everyone.
Happy Christmas, New Year. Thank
Happy
you for a great
Christmas.
evening.
Thank
Yes,
you.
happy Christmas,
Thank you.
everybody.
Happy Christmas, New Year. Stay safe,
Thank
everybody.
you. Happy Christmas.